Let's solve unit 3 questions. What is the output of following code? Let's see the code. A float type array is initialized here. 13.24, 1.5, 4.5, 5.4, 3.5. So this is A index 0, A index 1, A index 2, A index 3 and A index 4. Two float pointers are declared. J is equal to A. A will be starting from address of the first element. J is equal to A is actually address of A of 0. So J is here. K is equal to A plus 4. A plus 4 means 1, 2, 3, 4. So K is denoting the last element of A. So J denotes the first element of A and K denotes the last element of A. J is equal to J into 2. K is equal to K divided by 2. If J is an integer or a float or something, this into will be valid. If K is some other data type, it will be valid. But here they have declared them to be pointers. Pointer arithmetic is for plus or minus for binary operations. So if J is equal to J plus 2, it means it has to move 2 addresses. If K is equal to K minus 2, it has to move 2 addresses back. If J is going to be here, then if I say J minus 2, then it will come 2 addresses back. So the operations that will be allowed will be plus and minus. So into and division will be a part of other arithmetic. So it will not be a part of pointer arithmetic. So these two lines will throw error. Then you are printing and this will also work. There will be no issue. But unless and until you remove these two lines, you will always get an error. So if this is equal to J plus 2 and K is equal to K minus 2, K minus 2 will come back and both J and K will refer to the third element, that is A of 2. So when you run this code in a C compiler, it will give an error, invalid operands to binary operator. So float and float can be multiplied, int and int can be multiplied, but this is a pointer and this is an integer. So 2 is an integer and J is a pointer, so it has invalid operand. Illegal use of pointer in main function. Option 4 will be the right answer. Next question, what is X in the following program? Let's see the program. So first we will take this part. Array F PTR of 3. So pointer of array is declared and here you have the function symbol and then we have placed a pointer again here and we have an array again. So if you are very focused enough, from the name ARRFPTR you can derive 3 things. ARR stands for array, F stands for function and PTR stands for pointer. With these 3 words we can declare X is an array of 3 function pointers. Since function is placed here, this means 3 function pointers and it's an array of 3 function pointer because here you have the dimension of the array. Option number 3 will be the right answer. So if I say it is star X with some int or something, then it's a pointer. X is an array of 3 pointer, then there should be no reference in between, but only the dimension should be mentioned. Error in X declaration, there is no error, it is fine. Next question, what is the output of the following code? So here a struct is defined. So there are 3 fields totally. This is actually a string of characters. This is integer. And this must be some pointer that will be referring some other address location. We are declaring an array. In that we are giving input to this struct. The first record will be Nagpur. I will have 1 and pointer P will have A plus 1. Then Raipur. I will have the value of 2. Pointer will have the value of A plus 2. Then we have Kanpur. I will have the value of 3. and pointer will have the value of A. So whenever we say pointer is equal to A, we always say it refers to the 0th address. So I'll just place the index here. It is A of 0, A of 1 and A of 2. Nagpur goes to character, 1 goes to int and A plus 1 goes to pointer P. This is how I have written this part. Struct S1 pointer is equal to A. Whenever we assign an array to a pointer, it will always refer the 0th index. So pointer is referring to A of 0, which means it is referring Nagpur record. Now we are printing 3 strings. So first string is for A of 0 dot Z. Second string is for pointer Z. Third string is for A of 2 pointer Z. A of 0 dot Z. What is A of 0? Z field Nagpur. So Nagpur is printed here. Now what is PTR pointer? This PTR is again A of 0. So when I mention a pointer, I use this operator to denote the field. So pointer denoting the field Z is again A of 0. So this is again printing Nagpur. And next A of 2. A of 2 is this record. And in that P field, that is the pointer field. What does this pointer field say? It says it as A of 2 dot P points to A of 0. So it says A means A of 0, the first record or the 0th index record. In this case also we have A of 0 dot Z. So the field Z is again Nagpur here. So we are printing Nagpur again. So 3 Nagpur together. Option number 2 will be the right answer. So I'll just tell you what is there in the other 2 pointers. So if you take A of 0 dot P, it has A plus 1. A plus 1 means from 0 I have to move 1 position. So this will be moving to A of 1. A of 1 I have to refer dot Z. A of 1 Z field will have Raipur. When I say A of 2 dot P pointing Z, then it will be Nagpur. When I say A of 0 dot P to Z, it will be Raipur. Okay, let's see what is A of 1 dot P. So it has the value A plus 2. 0 plus 2 will be 2. Dot Z is equal to Kanpur. So this is A of 1 dot P Z field. Whenever I say A, it is referencing the 0th index. When I say A plus 1, it is index 1. When I say A plus 2, it is index 2. Next question, what will be the output of the following code? So they have given 3 integers. A is equal to 10 and B is equal to 10. So what is this 0x and 0? So 0x is a notation for hexadecimal digit and 0 is a notation for octal. Now A is equal to hexadecimal value. So how do you convert this to decimal? So hex to decimal will have in powers of 16 power 0, then 16 power 1, etc. It goes like this. So 1 into 16 power 1 plus 0 into 16 power 0. 1 into 16 power 1 is 16 plus 0, which is equal to 16. A will hold the value of 16. Now B has in octal format, octal to decimal, we will use 8 power. So 1 into 8 power 1 plus 0 into 8 power 0. 1 into 8 is 8 plus 0 into 1 is 0, which is equal to 8. So B is having the value of 8. Now C is equal to A plus B, which is equal to 16 plus 8, which is equal to 24. Printf C, 24 will be printed. The output will be option 2, 24. Though it may seem to be like small o, it is actually 0x, 10 and 0, 10. Option number 2, 24 will be the right answer. Next question. How will you free the memory allocated by the following program? So they have defined rows and columns and they have used malloc for allocating memory. What does malloc do? It is used for dynamic memory allocation. The format will be as it is given. So a pointer will be there. Then you have to use this malloc function along with the size. This is for memory allocation. Here the question is how to free it. So they have given three other functions, namely dalloc, memfree. Malloc will not be there for deallocating obviously, and the next is free of pointer. Memfree is not a part of this language, so let's take it away. What is dalloc? Dalloc is an objective C selector. When an object is no longer owned by any part of application. In other words, we can say when reference count on object drops to 0, the runtime will be calling dalloc. This line makes sure that we shouldn't call dalloc. It will be automatically called when there are no reference counts to the object. It has no work here. The only option left for us will be option number 4. Free of pointer will be the right answer for freeing up the memory allocated. Now let's have a statement about this. This deallocates or frees up memory space allocated by functions like malloc and calloc. It takes only one argument. The argument will be the pointer pointing to the memory location that has to be deallocated. So this will be the only argument and it has no return value. Since there is no return value, we will term it as void. The next question, the next set of 5 questions will be from computer graphics. Southerland Hodgeman method is used on. Southerland Hodgeman method is used for polygon clipping. Let's have only option 3 and option 4 and remove 1 and 2. So it's a polygon clipping algorithm. So if you take this polygon like this. So clipping means whatever part you want, that alone will be taken. The rest will be clipped from the viewpoint. 2 kinds of polygons are involved here. One will be the convex polygon and another will be the concave polygon. Convex polygons are correctly clipped by Southerland Hodgeman method. Option number 3, convex polygons will be the right answer. For concave polygons, we have an algorithm called Wheeler-Atherton. So if you take Southerland Hodgeman algorithm, when they applied it for concave polygons, it did not do it perfectly. It is a perfect fit only for convex polygons, so they don't use it on concave. Instead, they use Wheeler-Atherton for concave. We will also rule out option number 4. Next question. The clipping process in computer graphics is used for. So previously we saw polygon clipping. I just drew some random structure and I said this will be visible from the viewing part. So this part of removing other sides of the shape will be clipping. Now we will just see which matches the option. Adding graphics, it doesn't add anything. It doesn't copy anything. It doesn't zoom anything. It actually removes objects and lines. So option number 4 will be the right answer. The clipping process is used for removing objects and lines. Let me give you the complete statement. The clipping process is used for removing objects, lines or line segments that are outside the viewing plane. Why do we consider this viewing plane as a constraint to remove is because viewing window has a limited display area. So that becomes the viewing plane. Anything that is outside the viewing plane has to be removed. So that process is what we call it as clipping. Next question. Consider the rectangle with vertices 0, 0, 0, 2, 3, 0 and 3, 2. Just plot it in graph 0, 0, 0, 2. Then we have 3, 0, 3, 2. There is a scaling of 2 towards x-axis and 3 towards y-axis. The new coordinates of the rectangle are, we have seen about scaling transformation denoted by sx and sy. So what is actually scaling transformation is, when we have a coordinate called x, y, when it is scaled, the scaled size will be x dash, y dash, where x dash is equal to x into sx. The scaling factor here, and y dash is equal to y into sy. For now, we can take x to be the coordinates that is already given in the question, x comma y. This is sx and this is sy. So the scaling factor is how much it has to be scaled. This is x and this is y. So 0 comma 0. This is the new coordinates x dash comma y dash. 0 into 2 comma 0 into 3. This has to be multiplied by 2 and this has to be multiplied by 3, which is equal to 0 comma 0. So the same place it is. 0 comma 2. 0 into 2 comma 2 into 3. This will give 0 comma 6. Then we have 3 comma 0. 3 into 2 and 0 into 3. This will again give 6 comma 0. Next we have 3 comma 2. 3 into 2 and 2 into 3. This will be 6 comma 6. So the coordinates will be 0 comma 0, 0 comma 6, 6 comma 0, 6 comma 6. Here x-axis has been scaled up to 2. Sx is equal to 2. And this has been scaled up to 3. This is not there. This option is not there. The last one is also not there. So here it is 0 comma 0. It is present. 6 comma 0 is present. 0 comma 6 is present and 6 comma 6 is present. Option number 3 will be the right answer. Next question. Which of the following transforms in 2 dimension is used to resize a 2-dimensional object? Translation is actually for moving certain points. X can move for certain distance, Y can move for a certain distance. So it's about moving. Rotation is for rotating a part of angle. So your angle may be changed. Scaling is enlarging or diminishing the image. So previously we saw a rectangle which was in this size was turned to this size. This enlarging or diminishing will be called as resizing the object. Shearing means to change the shape and size of the object along x-axis and y-axis. If it is a rectangle, it may change to a parallelogram. So this is shearing. But when a rectangle is just enlarged as a big rectangle, or when a square is just diminished to a small square, then it is resizing. The transformation that is used to resize a 2D object will be option number 3, scaling. Next question, match list 1 with list 2. We will first go with Bezier curves. In Bezier curves content in computer graphics book, you have a line. Bezier curves are found in painting or drawing packages. Then in CAD systems. CAD is computer aided design. Painting, drawing, CAD is for A. A is mapping to 4. Option 2 and option 4 are ruled out. Next we will go with B-splines. We have usually seen this topic under Bezier curves, but B-splines here are meant for beta splines. Beta splines are generalization of B-splines. Here in beta splines we have two terms named bias and tension. So bias is denoted by B and tension is denoted by C. Usually they say B is greater than 0 for bias. So they have also given B-spline matrix is where B is equal to 1 and C is equal to 0. B-splines will go to option 3, bias and tension. A4 and B3. So option 1 is also ruled out. Option number 3 will be the right answer. Next we have sweep representation. Sweep representations will be for constructing 3-dimensional objects that have translation and rotational symmetry. So this line will be more than enough to explain sweep representation. So C will be mapping to 1. It is used to construct 3D objects. Next is natural objects. The only left out option will be fractal geometry. So we are mapping D to fractal geometry. So what is fractal geometry? It is the geometric shapes that have fractional dimension. They contain detailed structure at arbitrarily small scales having a fractal dimension. There is a statement called fractal geometry is the geometry of natural objects. This way we are connecting natural objects to fractal geometry. With this we are completing unit 3 questions.